Hey Cubs, welcome back. Today I'm going to go over Chapter 8, Section 1 lecture notes and do a couple practice problems with you. Uh, so let's go through some of these notes real quick. Um, so here we have the definition of a chemical reaction that has both the reactants and products mentioned. Now remember that reactants, those are the original substances. Those will appear on the left-hand side of the reaction arrow, and the products, those are the results of the reaction. Those will appear on the right-hand side of the reaction arrow. And then a chemical equation, that's going to represent using symbols and formulas the relative amounts of the reactants and products. And I say relative here because we look at leading coefficients to give us a ratio of how many reactants and products are used in that particular chemical reaction. So when there's no coefficient here, we can assume that there's a 1 there. We don't write the 1, but we have 1 unit of this particular compound. Here with water, we have 4 units of the water. So that leading coefficient is important when we balance chemical equations. So how do we know a chemical reaction has occurred? Well, there's 4 main ways: formation of heat light, production of a gas or a precipitate. A precipitate, that is a solid that forms when you mix together 2 aqueous solutions. A color change can also be an indication of a chemical reaction. So what are some of the requirements needed for correctly written chemical equations? Well, most importantly for us right now, the equation, EQN equation, must contain the correct chemical formula and reactants. Correct chemical formula for the reactants and products. So make sure you are comfortable with the naming rules from Chapter 7. Go back and review those if needed. The link to the practice quizzes for chemical names and formulas, that's still up on Mudge there under Chapter 7. So make sure that we are using correct chemical formulas and reactants before we even start balancing. So some other characteristics. The law of conservation of mass needs to be satisfied. So that means the same number of atoms of each element must appear on both sides of the chemical equation. So for example here we have 2 sodium atoms, we have 2 sodium atoms. We have 2 chlorine atoms because that 2 distributes just to the chlorine there. And we have 2 chlorine atoms on the product side. So it's important that we have the same number of atoms on each side. And that's essentially what balancing equations is all about, is making sure that we have the same number of atoms of each particular type of element on both sides of the equation. Now coefficient, that is the small whole number that appears in front of a formula here. In this case, sodium metal and sodium chloride in solution. And then the subscript, we're familiar with the subscript, that indicates how many atoms of a particular element or polyatomic ion are present within the chemical formula. Now for balancing equations, we're going to find that we can change coefficients, but we cannot change subscripts. Do not change the subscript once you have the formula properly written. Different types of equations. We've got a word equation that uses words. We have the formula equation that uses formulas. And then there's some symbols that are going to be used within chemical equations as well. Get comfortable with these symbols. Definitely the reaction arrow, the different states, solid, liquid, aqueous or aqueous for dissolved in water, and the gaseous phase as well. And then the other one I want to point out is this little triangle here. So it's the Greek letter delta. Delta indicates that the reactants need to be heated, that energy needs to be put into the system in order for the reaction to occur. You can also see that we have a chemical formula above the reaction arrow. That's known as a catalyst. So the catalyst is going to lower the overall activation energy so that the reaction will occur or occur faster. So it changes the rate of the reaction, and this substance is fully recovered after the reaction is complete. So it doesn't combine with any of the reactants to form a new product. It just exists as a catalyst there. And then the double-sided arrow right here, This is known as a reversible reaction. So a reversible reaction, once the reactants undergo a chemical change and form a product, they then can become reactants to go back to the original reactants. So it kind of goes both ways for reversible reactions. So the coefficients of chemical reactions, they indicate the relative amount of products and reactants. We're going to use this information more so in the next chapter when we talk about stoichiometry, but coefficients are very important. It indicates the relative number of moles present for a chemical reaction. So we'll use these coefficients as conversion factors in the next chapter. What chemical equations do not give information on? Well, they won't tell us if a reaction will occur naturally. Sometimes we can use theory to predict what might occur, but it doesn't necessarily tell us it will occur. Equations also don't tell us about the rate or speed of a reaction. Some reactions are incredibly slow. Some reactions are super fast. Think about the difference between the oxidation of the Statue of Liberty, going from its nice copper color to that green color. That took some time, versus a firework explosion. That's super quick. So it won't tell us about the rate or speed of a reaction. And it doesn't tell us about intermediates either. So these intermediates that are formed, we're not going to be overly concerned with them in the class, in this particular class, but intermediate reactions do play a role in chemical reactions. So how do we go about balancing chemical equations? Well, we're going to write the word equation and then follow these steps listed. You guys will have this copy available to you to review. So balance the different types of atoms one at a time. First, balance atoms of elements that appear only once on each side of the equation. Now, if polyatomics are present, we can treat those polyatomic ions as a single unit. One of the videos uploaded to the Mudge page goes into greater detail on how to treat the polyatomic ion as a single unit. Then I like to leave hydrogen and oxygen to the end after balancing all other elements. Remember, we cannot change the subscripts. And coefficients, they cannot go in the middle of a formula. Coefficients go at the beginning of a formula and do not change subscripts. So let's do a couple sample problems here. So we have AgNO3. Let me switch to this view. Okay, so that was, AgNO3. Name of that is silver nitrate plus copper yields copper nitrate and silver. So if we go back here, we can see our formula. So now we want to balance the atoms that appear once on each side. So we have silver, we have copper, and we have nitrate. We have silver, we have copper, and we have nitrate. So right now we have one silver atom on the left side, and we have one silver atom on the right side. So when these two values equal, it's balanced. But we need to complete the balancing for all of the substances present, not just silver. So we have one copper. So that's balanced. Nitrate, we have one. Nitrate, we have two. So since we have two nitrates on the right-hand side with the correct written chemical formula, we need to make sure we have two nitrates on the left side. Now we can't change the formula itself, but we can change the coefficient. So if we change the coefficient from the 1, we can make it a 2. Now this 2 is going to distribute to both the silver and the nitrate. So we have two nitrates now. So nitrates are equal. Now anytime you change a coefficient, go back through your different substances to make sure that you have a balanced chemical equation still. Because we added the 2 to balance out the nitrate, this 2 also affects the silver. So instead of 1 silver, we now have 2 silvers on the left-hand side. We only have 1 silver on the right-hand side, so we need to change the coefficient here. We need to place a 2 in front of the silver, and we end up with 2 silvers on the right-hand side. So now we have 2 silvers. That's good. We have 1 copper, 1 copper. That's balanced. And we have 2 nitrate units, 2 nitrate units, and that's balanced. So this would be our balanced chemical equation for that first sample problem. Let's take a look at a couple other practice problems here. So we have magnesium plus nitrogen gives us magnesium nitride. Then we have, let's jump down to the last one there. We have CH4, methane plus oxygen gas will react to produce carbon dioxide and water. Okay, let's go back to this camera shot. So let's balance this first one here. We've got 3 magnesiums and 1 magnesium. So we have magnesium and nitrogen present. Magnesium and nitrogen. We have 3 magnesiums on the right side. So we need to change the coefficient. We cannot change any subscripts. We can change the coefficient, however. So we'll place a 3 in front of magnesium. Now we have 3 magnesiums on both sides. We have 2 nitrogens, because remember this 2 indicates how many nitrogen atoms we have within the chemical compound. And over here we have 2 nitrogen atoms as well. So that is another balanced chemical equation. Let's take a look at this combustion reaction between methane and oxygen gas. So we have carbon, hydrogen, and oxygen, carbon, hydrogen, and oxygen. So when we look at carbon, the carbons are balanced. Okay, that's good. Then we take a look at hydrogen. We have 4 hydrogens on the left-hand side. Right now we only have 2 hydrogens on the right-hand side. So we can change the coefficient. We can place a 2 in front of water, and this 2 distributes to the hydrogen and the oxygen. But right now with hydrogen, 2 times 2 is 4. We have 4 hydrogen atoms on the right side. So those are balanced. Now let's take a look at oxygen. Oxygen, we have 2 plus 2 oxygen atoms. So we have a total of 4 oxygen atoms. Now on the left-hand side, right now we only have 2 oxygen atoms. So we need to add we need to get a total of 4 oxygen atoms. So we can change the coefficient here to make it a 2. Now that 2 distributes to the oxygen, and we have 4 oxygen atoms on the left side. So just to double check, we have 1 carbon, 1 carbon. We have 4 hydrogens, 4 hydrogens. And we have 4 oxygens and 2 plus 2, 4 oxygens on the right-hand side. So that would be our balanced chemical equation. Now I'm going to upload another video going through the practice problems for this section found on page 258 and 259. So these practice problems here will be uploaded in another video. Let's finish up this lecture. So thermochemical reactions. Remember in science, if you don't know what a term is, break it down into usable parts. So therm meaning heat, chemical reaction. So it's a chemical reaction that involves energy being released or absorbed as heat during the reaction. So exothermic reaction, remember break down the word if you don't know. Therm meaning heat, exo outside. So heat is released. That means energy is going to be a product. Then we have endothermic reactions, endo, inside, therm, heat. So that means heat is going into the reaction. RXN is short for reaction. So that means that heat is absorbed. The energy quantity would be on the left-hand side. It would be on the reactant side. Now just to Reminder about Chapter 7 for classifying different compounds. Acids, they usually begin with a hydrogen, not always. Bases usually end with OH or hydroxide, not always though. Ammonia, NH3, that's a base that doesn't fit that rule, but usually for our class they're going to end in OH. Metallic oxide, right there in the name it tells you it's a metal combined with oxygen. Salts, composed of metals that are not bases or metal oxides. Salts usually combine a halogen with a group 1 or group 2 metal. And then we have other compounds. Some of these are organics or don't fit those particular categories. So take a look at the Mudge page for more details about the homework, and I will post another video going over practice problem C, D, and E. Have a great day, Cubs.